Hi, everyone. I'm very excited to welcome you to the Building on AWS workshop brought to you by CloudVisor and BitDegree. So CloudVisor is an AWS partner operating in the Baltics and Nordics who work closely with AWS to support current and new AWS users in the region. And their main business line is AWS Resell. Many companies in the Baltics have found it highly beneficial already. So if your company is currently using AWS, I definitely suggest you check out the benefit packages that they offer as a bonus for your AWS spend. And next to that, as you can see from this workshop, CloudVisor is building an AWS community in the Baltics. And BitDegree, which is where I'm from, is very glad to be part of the journey. BitDegree, on the other hand, is this up-and-coming edtech startup that just launched their Certified Cloud Practitioner course, which will prepare you for getting certified in no time. Having worked on it for months myself personally, I can confirm that the course is the most up-to-date and innovative educational experience out there. And it's carefully designed to cater to all learning styles. So if you're a beginner, definitely check it out. So if you're here, I am going to make an educated assumption that you are already slightly familiar with Amazon Web Services. But obviously, AWS is monopolizing the cloud computing industry. It offers over 200 different services globally, so it may be hard to know where exactly to begin. But don't worry, that's why we're here. So who are we? So my name is Yeva, as you can see, and I will be your moderator for today. I won't be speaking that much. I'm just an educational content creator from BitDegree ACADEMY. And more importantly, I think for this workshop, I was also in most of your shoes just a few months back. Like in September, I really didn't know what cloud computing was. But by December, I had finished an AWS Cloud Practitioner course from scratch, together with today's speaker, Laurynas Tumosa. And Laurynas is who we're here for. When he isn't mentoring our students, Laurynas works as a cloud and DevOps engineer at seca, which is a global leader of medical precision technology. His expertise with AWS is honestly astounding. Laurynas has passed 4 different AWS certifications, with the most recent being a specialty level certification in machine learning. As I've already mentioned multiple times, Laurynas is also one of our instructors at BitDegree Academy. I can definitely say from personal experience that working and learning from him has been an absolute pleasure. Now, before we jump into the workshop itself, I would like to take a moment for some general housekeeping. So with this workshop, we want you to get the best of both worlds. So like the theory and the practice. And that is why Laurynas here will give you an overview of AWS, its global infrastructure and services like Elastic Compute Cloud and EC2, autoscaling, load balancers, maybe some RDS will pop in there as well. And then we will go on to see how you can set them up for yourself. So there will be a demo. We unfortunately have limited time today, so the introduction is going to be pretty general. But if you do want to delve deeper and become a certified cloud practitioner yourself, you can enroll in our BitDegree Academy. We're even offering 35% discounts today on 3 different offerings. You can see the promo codes for them on the screen. Just to claim these, you can use the relevant promo code when purchasing your package. If you have any general questions, you can email us at academy@bitdegree.org. But that doesn't mean you cannot ask questions. We want you to ask questions. In fact, there's no such thing as a stupid question here. So if you have any questions during Laurynas' presentation, just jot them down in the chat or the Q&A section, and I will make sure they get answered during the workshop or in the Q&A part in the end. Now, for the demo part. So you should have received login information for trial AWS accounts that you can use for the live online practice tasks. If you want to, you can still email CloudVisor and they should send you the login information ASAP. As this is an introductory workshop, we know it might be difficult to follow every step closely. Thankfully, Laurynas was kind enough to prepare some step-by-step instructions, and you should have received those in your email at 2 p.m. If you feel yourself falling behind, feel free to refer back to those, either during the demo or after this workshop ends. So having said all that, this is the most I'll be speaking for today, but I am happy to finally pass the virtual microphone to our true star of today, Laurynas. Are you ready to chat?
Yeah, I'm here. Thank you for the introduction, Yeva. So yeah, I'll share my slides for now. So we will start from the slideshow. So just to give everyone a brief introduction about AWS, because yeah, not everyone might be on the same page. So just to simply get everyone on the same page here. And then later we will move to the workshop part where we can basically yeah, go to the live demo and see how to work with AWS environment. So as yeah mentioned, I work at seca as a DevOps engineer. So seca has been in business from 80s, and it has been through a lot of transformation, as you know, because it's been such a long time, and most recently becoming cloud native and digital company. And for that, yeah, we adopted AWS Cloud, and it has been amazing experience because we are able to innovate and work much faster. So I assume since most of you are here today, you already know about something about benefits of the cloud. Yeah, but this has been very transformational for our business. Yeah, and also we are hiring for front-end engineers and mechanical engineers in both Hamburg offices and Vilnius. So if you are interested in any of these positions, please let me know. So without further ado, let's move to the cloud concepts, basically to discuss what is AWS Cloud and what benefits it provides. Yeah, so AWS Cloud is simply a cloud service provider with pay-as-you-go resources with like different services such as infrastructure, storage, databases, and many more. And yeah, let's discuss first AWS value proposition. So firstly, availability. So with regular data centers, some outages might happen and you might lose some of your data or something like that. And AWS with its global infrastructure can provide constant access to resources. Yeah, also it's very flexible. So with regular data centers, you usually have to plan maybe 5 or even 10 years in advance about what kind of resources you want to buy, what kind of hardware you want to buy. And later you might see that, for example, one of your servers that you buy, there might not be as useful for your application and as its architecture changes or it grows. And with AWS, you can flexibly pay for only what you use. Yeah, also it's very secure. So AWS says that security is job zero for them. So they make sure that all the features has security features built in, and it's also your responsibility as developer to make sure that you configure resources correctly, but AWS make sure that you have all the resources available for you to make your applications and infrastructure secure. Yeah, also costs. So because of economies of scale, AWS can provide can have like better deals with hardware manufacturers to buy the hardware, and they always reduce their prices. So even I think this week they sent a couple of announcements that they reduce pricing for the Glacier, which is archive service. So by using AWS, you can basically save money as time goes because prices usually go down instead of going up. And also, yeah, with new infrastructure, you can move to more efficient hardware, which will be also cheaper. And also, but maybe even most important is agility. So with AWS, since you don't need to plan anything in advance, you can experiment, launch new services, check how they work for your company, and that's kind of really cool because you can run experiments that are cheap and they don't cost much money.
Can I just pop in for a quick question? I wanted to ask you about the AWS free tier, because you mentioned we can experiment. So could you tell the people who don't know that much about the AWS free tier, what it is and how AWS actually allows you to experiment for free?
Yeah, there's also like very generous free tiers. So when you first register your accounts for 12 months, you get, I think, like many services completely free or some of the services for free. So for example, you can run up to up to 1 month of one EC2 instance and one database instance for free. So it's simply if you experiment and start with your business to use AWS, you can get for free and then see how they work for you. And also they provide free trials for even other services. So if you think, for example, even after a year, but if they launch new services, they usually provide like a month free service that you can basically check how it works for you. And also there are no like commitments for services, so you can try it and completely shut it down if you see that it's not beneficial for yourself or your business. Okay, so let's move to technology part. So to discuss the global infrastructure and regions. So this might be if you are from the data center part, or you're used to like working with your own servers, it might be a bit different concepts. Because yeah, AWS has, I looked up today, and it's actually 25 regions that are launched already, and they plan to launch 5 more regions as well. So yeah, it seems that the global expansion is never comes to end, and yeah, the new data centers are planned in Spain, and recently I think there was new data center launched in Stockholm region, so now it's fully operational. So you can see that AWS basically launched data centers where their customers are. So so if your business is planned to expand globally, you can bet sure that AWS will have some regions there as well in some time. Yeah, and to discuss the concept, so a region is the physical location in the world which contains multiple availability zones, and each region is completely isolated from one another. So if you launch some service in one region, you can be sure that this data never leaves the region. So for example, if you have to be compliant with GDPR and you want to only store your data in European region, basically you are certain that AWS will never transfer the data out of the region. And the availability zone is just like basically to make you more resilient. So they launch multiple data centers within the same region, and that creates availability zone, which is basically isolated data centers. So each of these availability zones are completely on different electricity, internet providers, and flood zones. So basically, even if some flood happens in Stockholm, for example, and city is ruined, you can still make sure that at least one availability zone perhaps will survive and you can still be operational. Because yeah, these data centers are also some distance behind from each other. So they're not really close to each other, but they're also connected to very fast network cables. So we can make sure that the data transfer within these availability zones is very fast actually. Yeah, and this is the graph that can basically be used to kind of understand it better. So you can see there are 2 regions, EU West 1, which is Ireland, and another one in London. And all these regions have at least, I think it was at least 2, but now it's at least 3 availability zones. And these availability zones are connected to the very high throughput network cables. So when you launch something like a virtual machine, it goes to it launched into specific availability zone, but you can also transfer it and stop and launch it into different availability zones and stuff like that. Yeah, and this is how it looks in AWS console. When you log into your AWS account, on the right hand, you can see all the regions that are available. And probably you can experiment and see where your customers are and pick the most closest region to your customers, or even use multiple regions with multi-region AWS approach. Okay, so now let's move into compute and introduction to EC2. So EC2 is the web service that provides secure and sizable compute capacity in the cloud. So basically just virtual machines that you can launch in AWS Cloud. Yeah, so they are virtual machines that you can launch, and there are multiple sizes, multiple instance types that are specified for specific use cases. For example, some of the instances have a lot of RAM, and some of them have a lot of CPU power, or there are also some REM chips which are like using different CPUs. So yeah, AWS also recommends to try multiple instance types and see what works best for you, and yeah, because there might be different cost optimization parts that you can do with selecting the best instance for your application.
For those who are complete beginners, because I know that this question rose to me when I first started, could you just like explain what a virtual machine even is?
Yeah, so virtual machine is basically like a virtual computer, which is virtualized hardware, and AWS have like really big servers, and there you can launch virtual machine, and you specify how much RAM you want, how much CPU you want, and it creates an instance for you that you can use to launch your software. So the same as you would probably use VirtualBox or yeah, on your laptop to launch some virtual servers. Yeah, so this is how it looks like. So within region, you create subnets, which is basically by default is like virtualized network layer that you can use. And in these subnets, you launch some virtual machines or EC2 instances that can be used to run compute tasks or run web servers and stuff like this. Okay, so now let's move on to the demo part. So, yeah, 1 second. Okay, so those who have AWS account, hopefully you are all logged in to your console. So I'm already here. So if you're not logged in, so I can show you how to log in. Yeah, so when you logged in, you will be greeted with this login screen, and you should have your account ID and also your username and password that you enter here. But I already done that. So when you logged in, you will be greeted with this screen with AWS Management Console. So as shown previously, here you can see all the AWS regions. So I picked Stockholm today because this is the region that is closest to me that I can use. But probably if you want, you can pick a different region to see how it works, but I will stick with Stockholm this time. So when you go to like AWS services, you can see that like there are a lot of services, which can be like really confusing and daunting at first. But from my perspective, I think like as a beginner, you should focus on like the main services, which are like EC2 and other services that I will talk about this day, because these services are like the most building blocks of AWS. And if you know them, you can basically learn other services as well. And it's important to stick to the basics and learn them before like diving deep into other services. So I can click on EC2 to go to EC2 console. Yeah, and here I'm greeted with instances that are running security groups. So security groups are basically just firewall rules that I can have for my instances. So if I click here, I can see like there is default security group that was created by AWS. So let's go back to the EC2 dashboard. Yeah, and plan for the day is basically to see what would happen. So for example, imagine if I am working for a ice cream shop, and they decide to launch internet web page because they might need, because since now it's still lockdown procedure, lockdown is here, so probably they want to create something like a web page that they can sell ice cream using that web page. And for that, if they decide to use AWS, you probably will start by using EC2, where you can create a web server that will operate as your store. Okay, so to launch instance, I can go either click here to launch instance, or I can go to this EC2 dashboard and here, yeah, click launch instances to launch a new instance. Okay, and here I'm greeted with a lot of different options for operating systems, and even they have some pre-built software with AWS Marketplace and community AMIs. So for
What
example,
are community AMIs?
Yeah, so AMI is simply Amazon Machine Image, which is basically pre-built image that has some software built in. So AMI can simply be some operating system like Ubuntu, yeah, as you can see here, Windows Server, Red Hat Enterprise Linux, or even some like pre-built. So they have, yeah, Marketplace, they have like WordPress certified, for example. This is the complete WordPress package. So if you plan to run WordPress site, you can launch this and that it will have WordPress pre-installed and configured ready to be used. This is that it helps to save some time and money because you don't need to configure all this stuff. But today we will start and configure our server ourselves. So let's go and click this. Yeah, Ubuntu Server 2004 LTS. And yeah, click select. Okay, so here I'm able to pick the instance type for my virtual machine. So you can see, yeah, there are a lot of instances and they have different CPUs and memory available there and also some network performance. But generally, if you just started, you can use this.
Why some of them are blocked?
I think this might be because this is probably okay. Oh, this is not supported by our architecture. Yeah, because probably this is different architecture of the CPU, and because we chose yeah, AMD 64 architecture, and this is probably REM architecture. Yeah, probably when you started, you don't want to launch these instances because these are quite expensive. And to get started, this instance, T3 Micro, it's eligible for free tier, as I said. So when you get started, you can use it for the first 12 months, and this is 750 hours, so it's approximately, yeah, you can run it for a whole month without any charges. So and experiment with it. Okay, let's click next to configure instance details. Okay, so here as well, I'm greeted with a lot of options. So, but mostly you can just simply ignore most of them. Yeah, important is the networking part. So AWS always creates the default VPC, which is basically your virtual private cloud where you can launch your instances and they have like network addresses. So in these cases, they can communicate between each other, but they are not reachable by outside world. So they get this private IP space that they can use. But default VPC is always created in your account. So probably when you go into production use case, you should create your own VPC. But yeah, VPC design and creating VPC is like quite a lengthy topic. So it's not the scope of this talk. So if you want to learn more, just yeah, either go online or go to Cloud Practitioner course because they explain VPC design pretty good. So yeah, we can click, I think, add storage. And here I can select and attach additional volumes for storage of my instance. So by default, it gives 8 gigabytes of storage. So it's not very big, but it will be enough for this workshop. So next I can add some tags, for instance. So tags are simply just key value pairs that can be used to identify AWS resources. So for example, I can enter environment. Environments and dev. And I can also give my instance a name, but maybe I'll do it later to show it how it works. But yeah, so this should be enough. And then next we'll go by configuring security group. So as I mentioned, security group is a simple firewall rule that you can use to connect to basically control the traffic that can leave and enter your instance. So by default, when you create security groups, they allow all outbound traffic, but you have to configure inbound traffic. So I'll click to create new security group here. I will enter the name, web security group, web has a G, and I will enter the description. Okay, so for now I will leave it as default. So it will allow SSH, basically, which is secure shell connection that can be used to connect to your instance. And I will leave it as it is. So as you see here, AWS notifies me that it will allow all IP address to access our instance, which is not advisable. But since it's just a workshop, I will leave it as it is. But for example, in your scenario, in different scenario, yeah, we need this as leave it like this. But when you are working in production use case, you probably can limit it to your IP only. Okay, but now let's leave it as anywhere. Okay, now click review and launch. And here I can see all the details about my instance. And I will click launch. Yeah, and I also need a public private key pair to connect to the instance. So I will create a new pair. I'll name it web. And click download. And launch instances. Okay, so I can click somewhere to view instances to see how it looks like. And I can see that the instance is running already. So yeah, since I didn't give a name, I can name it here as well. So I can click this edit button and create a name here, web. And what it simply does is basically create a tag with name, key name and value web. So this is quite important to be able to identify all of your resources, because when you're working in your maybe company account, there might be a lot of resources. So it's important to give tags right to be able to identify all these resources.
Could you tell us about the file you downloaded, which I saw was a key pair file?
Yeah, so the file I downloaded was basically public key that can be used to connect to the instance. Basically, what means that when I use SSH agent, which is secure connection, I will need to provide this key to connect to the instance, because otherwise it won't let me connect to the instance. So it's important to keep this key pair safe. But yeah, since AWS provides many options, so in this case, we will not use this key because we'll use different way to connect. So I can click connect here, and you can see different instructions. So if I needed to use this key, I can click here, SSH client, but the problem with that is that it's different for different machines. So for Windows, it's a bit different from Linux and macOS. So since I don't know what operating system users are using, so we'll use this EC2 instance connect, which basically creates a web terminal that you can use to connect to instance. Yeah, and this is why I left the SSH part public, because it connects to the EC2 instance from like AWS assigned IP space, and I'm not sure which IP address it is. So we can click here and click connect.
Sorry to interrupt, Laurynas. One question that came was if it's possible to download the public key at a later time, because one of the people forgot to download it at the creation time.
Yeah, it's actually not possible to download it, so that's why you must keep it safe. But there are some ways that AWS can provide. So for example, if you forget the key, AWS can sometimes rescue the instance, but other than that, you must relaunch instance with different key. But in this case, we won't need this key, because actually for this workshop, yeah, we're using EC2 Instance Connect, so you can connect using the web terminal without even using that key. And you can see here that I'm already connected to the instance. So to show you again, maybe someone missed it. So yeah, you go to instances, you make sure it's selected and click connect, and then on EC2 Instance Connect, click Connect again. And it automatically understands that my username is Ubuntu, and because this is Ubuntu operating system, and lets me to connect to the instance. Okay, so here you can see that I am already in the Linux environment, and I can see run all the Linux commands that I know. So firstly, let's install the Apache web server to be able to launch our web page. So firstly, I will run sudo apt update to get the updated package versions. Okay, so you can see like even 40 packages can be upgraded, but perhaps we won't run this time because they're not quite important this time. But if you're running production workload, you should definitely keep your instance upgraded because it can be some kind of security risk if like old version of the package had some security vulnerability that wasn't resolved. So, but now let's just install the Apache web server by running this command sudo apt install Apache 2. Okay. And here it is, the installation is done. So hopefully now I can use the public AP and go to the website. Yeah. Okay. It's doing something. But you can see it's not loading correctly. So let's try to troubleshoot, understand where is the problem. So maybe I can check if the web server is running by using this command. Systemctl status Apache 2. Okay. So it shows that the service is running. So let's try one more thing. Let's try to use curl to see if it's actually running. Or yeah. You can also see that something is returned. So probably something wrong from AWS side. So let's go to the instance. And yes, you perhaps already know the problem was with security group that it doesn't allow access from port 80 because here I'm only configured 22 port range, but not 0.80. So that's this traffic wants to reach that instance, but since firewall block all the ports that aren't allowed by default, I need to open that port. So yeah, I can go to EC2 instances, click on the instance, go to security, click on the security group here, and then I will edit the inbound rules and add. So I can either do add port by selecting HTTP here, which automatically recognize that for HTTP you would use port 80, or I can simply add rule here and then enter 80 here, which will be the same actually. And here I can click anywhere, which will create these two rules. And I can also add command. So basically HTTP from anywhere, which can be quite important because if you have many security rules, then these commands can be helpful to understand if they are actually required and what are the point of these security rules. Because sorry, if you don't add any description, then it might be confusing at the later part where you actually don't know if these rules are required, and then later you might delete some rules, but if they were used by your application, something might get lost and your application might not be working. So let's try again. Let's save this rule. And you can see that this is applied almost instantly. And if I refresh again, yeah, so yeah, I'm redirected to basically default Apache 2 Ubuntu web page, and they even set like if I want to, what I need to do to replace it and create my own web page here. So yeah, we can actually do that like now. So let's remove the, okay, let's go. So let's create a new file, touch index HTML, and go nano index HTML. So let's write here, hello from EC2. So probably in the real world, you would, yeah, create your web page externally, and then you can use Git or something like that to get this web page to the server. But here I'm just created like a new index page, and then let's delete the previous page. Maybe this console doesn't allow to copy, so I will write it manually. HTML index HTML and copy. Okay, I can do it like this, and I can run sudo and use this two symbols to basically try this command as sudo user. So now if I refresh it again, okay, let's refresh the web page. So here I'm greeted with hello from EC2. So to see that my web server is running, yeah, but probably in the real scenario, you could install some additional software on the machine. So for example, something like PHP web server or Python for the application or anything else. So it can work as a real application. But yeah, we're not going to do this time, since it's mostly for introduction about AWS, not for application development part. Okay, so I can leave it like this, and yeah, and I have my web server. This is running, and it can handle some traffic. And yeah, so AWS also provides some monitoring, so I can see the CPU utilization. Another part, so network going in, network going out. Yeah, but for more information about this, you can also learn more in different courses. Yeah, but today let's see, for example, what would happen. So yeah, I have this also IP address, which is public IP address that can be accessed by anyone. So anyone around the world, if I give this IP address, they can access my web page. So or if I later install some web store. Yeah, but the problem with this approach is that basically if something happens and the system is stopped, let's see what happens. So immediately my web page is down. So in the next part, let's discuss how can we resolve this problem and basically decouple our servers from the front end part. So let's go back to the slides. Yeah, so to solve the problem, we can use Elastic Load Balancer. So as you saw, like, yeah, what we did today was users were accessing EC2 instance directly, which is probably not great, because what happens if this instance shutdowns or if IP address might changes? Yeah, that would create a problem. And also many users can access the instance at the same time, and it can run out of the CPU or memory, and it will also create a downtime. And even if my business is small, but any downtime, especially, it's not great, and users might leave your company and not want to do business with it ever again. So you must ensure that your website is probably always available. So to do that, AWS provides a service which is Elastic Load Balancer, and it actually creates a DNS records that your user can use to access your application. And in the background, it talks to all the servers that you have on the backend side. So it simply can handle all the requests from the users and then forward it to appropriate backend server that can handle this request. Yeah, so Elastic Load Balancer, it automatically distributes incoming application traffic across multiple targets. So it can work with EC2 instances, container, IP addresses, and yeah, Lambda functions, which is AWS servers that can run function as a service. So basically, you can just simply write application code without even thinking about servers. Yeah, and how does it work? Basically, your users access Elastic Load Balancer, and it forwards the request to appropriate backend server. And for example, if one instance is down, then Elastic Load Balancer knows about it, and it simply stops sending the traffic to that server and sends to different servers. Yeah, this is what's shown in this diagram here, probably.
If you have multiple EC2 instances, how does ELB decide which instance to send the traffic to?
Yeah, so a different algorithm that I think by default it uses round robin. So basically, when first user comes, it sends to the one instance, then later it sends to different instance, and it goes around like this. But if your application needs to make sure that users always goes to the same server, you can also set it up like that. Yeah, and also with application load balancer, you can use advanced settings such as basically host-based routing or path-based routing. So basically, based on specific path that user enter in your web page, it can go to specify a backend instance there. Yeah, or even you can select based on host name. So for example, if you go to admin application, admin dot your domain, it will go to admin EC2 instance, and if you select different domain name, it will go to different instance. Yeah, and the advantage that Elastic Load Balancer provides is that it also creates a health check that monitors the health of all the resources that traffic are being routed. And if something fails, it can basically, by default, send the traffic to different instances. So this is kind of very important that even if something fails, load balancer can figure it out. Yeah, but yeah, so let's try to use load balancer in our demo. Okay, so probably let's firstly, because now we have only one instance, and in your handout notes it was also only one instance, but to make it more fun, let's make it 2 instances. So for do that, basically, yeah, since we created our instance from Ubuntu, but now since we already modified the image, we can actually create a new image. So let's try to do that. So basically, we just create a new AMI that can be launched to launch the instance with same parameters as I already configured. So when I create the image, it will already have Ubuntu installed, and it will already have our web server installed and our index page that I created. Okay, so let's leave everything else by default and click create image. And here in image, you can select AMI. And you can see the image is pending. So AWS is trying to create the image, and it will in the background create. So by default, when the instance is running, AWS will reboot the instance to ensure the consistency of the file system. But since the instance was stopped, so they won't need to reboot it this time. So it should be quite quick to create. Okay, since it's running in background, so maybe we can start and let's go to the load balancer part. So here on the left side, search for load balancer. It's at the very bottom. Click here. And let's create a load balancer. Yeah, so here I'm greeted with all the different options. So for most parts, you just want to use application load balancer. Yeah, which works with at HTTP level. And network load balancer is more for like if you need very high performance but less features, you would use network load balancer. Yeah, and this is probably quite a new service because I haven't even known that this existed. So let's go. And yeah, for name, let's select web load balancer. So since our application is internet faced, let's select internet facing. Yeah, and this is default VPC, and I need to click to enable all the different availability zones in these. Yeah, so enable subnets in each availability zone. So so yeah, since this is default VPC, it has only one subnet in each availability zone, so it's pretty easy to do that.
When we launch the EC2 instance, do we choose the subnet?
Yeah, so by default, it uses the default VPC and default subnets. So we didn't need to do anything here, but if you select your custom VPC, then you need to probably think more about it and yeah, design your own network. But this is by default AWS design network that we can use. Okay, next let's click to configure security settings. Okay, so I will also need to create a new security group. So let's name it web load balancer. Yeah, and since our application listens on port 80, I would leave it as 80. Okay, and then let's configure a target group, but probably before doing that, I need to go back to EC2 console to make sure that our image was created and is available. So let's go back and see AMI. Okay, yeah, it's available. So now let's launch our stop instances again. Let's start. And also launch the new instances from the AMI image that we created. So I can click my AMIs and I can see that my web image is available. So we just click select. Let's leave it as T3 micro. And let's go to the settings again. So yeah, we'll leave everything as default here. Again, as default. Okay, so I need to add new names. Name. Environment. Yeah. Okay, so now we can because we already have security group for web, so let's use it. So I can see it here, web security groups. I will select that, and I can see all the rules that it has. So this is what we need. And next, let's click review and launch. Yeah, and since we already have this key pair web, so I can launch it with the same key pair. Okay, so it gets like, yeah, new public IP, and I can use it to see if it works. Let's check it out. Let's copy and paste in the tab. Okay, it's still not running. Okay, now it's running. So I can see that, yeah, this image is already with my file that I modified. So now I have two instances that can be reused as our web application. So, and probably let's check it out. Yeah. So now even with one instance dies or something bad happens, I have a backup plan that I can use. Okay, so let's get back to the load balancer. Okay, so it needs a target group. So target group is basically where load balancer sends its traffic. So here you can see, I can see instance, IP, or Lambda function, but in that case, since we are working with EC2, let's select instance. And yeah, as mentioned, ELB do the health checks. So in that case, it will use HTTP to check on the default path to see if the backend instances are running. Okay, so now let's register some targets. And yeah, if you can see, if automatically finds the instance that I'm running and suggests to add them to the load balance, which is quite useful. Okay, let's click review. Yeah, and so there you can see all the settings, and I can create the load balancer, which will also take some time, but it should be quite quick. Yeah, and load balancer, when you provision the load balancer, instead of IP address, you get the DNS name, but you can use this DNS name to register with like your company name or something like that using either Amazon Route 53, which is Amazon DNS servers, or any other DNS service provider.
So a question we got was, can you do a SSL termination on load balancer?
Yeah, so if you use secure listener, then you can listen to port 443, and you can either terminate SSL as the load balancer level, or you can generate certificates and use SSL even between your load balancer and your instances. So it's up to you to configure that. But yeah, if you want, we can later also configure this load balancer to use secure listening instead of port 80. It's provisioning, so let's wait a bit.
And in that time, we can also answer another question that we got from Nikos, which was, instead of creating a new AMI and launching it, could you choose to just press launch more like this? Or does that work in a different manner?
Yeah, I'm not exactly sure like where is this option to launch more like this? But probably, yeah, if I launch instances, I can launch more instances. So for example, I can create this AMI. And where is that option to launch more instances? Yeah, so I can click, like 7 instances, and then it will launch 7 instances of the same AMI image. So yeah, that can be used to launch more instances of the same image. Yeah, I think somehow the AWS is quite slow today. I'm not sure why. Because when I was testing it, it was a bit quicker than that, but maybe. Yeah, maybe we can also add like secure listener right now. So if to do that, I can simply select HTTP 443 and then redirect. Maybe not redirect. Forward to target of web. Yeah, but for that I probably need to SSL certificate, and we won't be able to do that because we don't have our own domain name. So we just use Amazon private domain name. So basically, you need to firstly create your own domain name, and then you can request SSL certificate with that domain name. Yeah, so we can go. Let's go here, and here I can see that yeah, the load balancer is running. And it probably redirects the traffic to both of the instances that are running. Yeah, in the console I can see also some metrics. So yeah, request count. So we can see we generated a couple of requests by going to the load balancer. Also 500 error counts and 400, which is basically if something bad happens with the backend, or 400 error counts. That means that something is not found. And you can also monitor target response time and many other things that you can use to keep track of your application. Yeah. And also here I can see listeners. Let's go to web. Okay, let's go to monitoring. Okay, so here I can see what happens, for example, if the instance is unhealthy. So it does health checks every 30 seconds. And after 2 consecutive health check failures, it marks instance as unhealthy. And when it launches a new instance, if it takes 5 health checks to make it successful, and then later it can send customer traffic. So for example, when you register a new instance with a load balancer, it firstly makes sure that application is healthy and running before sending the traffic to the instance.
And what is an unhealthy instance? Is it just simply one that fails, or is there another threshold that it has to pass?
Yeah, it simply waits for 5 seconds to return the successful HTTP 200 code, and if it doesn't return, then it marks it as unhealthy. So even we can stimulate it. So for example, if I let's maybe let's stop this instance to see what will happen here. So now the instance should be stopped. Let's try to use public IP address to enter it. Yeah, it's not running. And let's see what it looks like on the load balancer side. So now it still shows that the both targets are healthy. Yeah, and now it recognized that the target is stopped. And now if I go here, it will only send traffic to the second instance, so my application is still running and the users are not receiving any errors on their side. And if I launch it again, then it can, let's see what will happen. Yeah, so now the instance is running, but the load balancer is still waiting to see if it's actually successful, because as here is specified that it waits for 5 consecutive health checks to be successful. Yeah, so only after a couple of minutes it will be registered with the load balancer.
And Simeon also asks about drifts. So I'm guessing he's talking about configuration drifts. He's asking, do you need a new instance after it drifts?
Yeah, so there are different ways to update. So probably if you use EC2, the most used approach is, yeah, basically launch a new AMI. So basically, yeah, to update one instance, create an EMI image for that, and then you can use the load balancer or autoscaling groups to replace your instances with a new image. So that would be the most appropriate way, because, yeah, if you simply update the different instances manually, then the problem might be that they can receive different updates and they can be in the different states. So usually you can update one instance, check if it works, create a new, basically as we showed here, create a new image. Yeah, create a new image and then launch instances from that new image. Yeah, I think that's all from the load balancer part. Yeah, let's see what else we have. So yeah, so we've covered only 2 services now, but like, yeah, so when application grows, you might need to use different services. So RDS is the database service that you can use for persistent storage. So you would usually install your web server on EC2, and then for persistent storage, you would use something like RDS database. Yeah, CloudFront is the content distribution network that can be used for storing your front-end assets, and it automatically replicates the traffic to closest regions to the customer. So it has like many locations around the world, and by using CloudFront, you like get your traffic from because the traffic uses AWS infrastructure, so you don't need to worry about your infrastructure handle this traffic. Also Elasticache for in-memory caching. So in real world scenario, you would probably create your own VPC for networking. You can also use Route 53 to create DNS records. So probably in the real scenario, you won't use this long DNS name, but create something like your company name.com or something like that. Yeah, and auto scaling to scale up or scale down your instances. Yeah, so if we have time, we can just discuss a bit more like about RDS and auto scaling as well. Yeah, so RDS is the managed relational database service in the cloud that can be used for persistent storage and stuff like that. And it supports multiple database engines, both open source and closed source engines. So MySQL, MariaDB, Oracle, Postgres, SQL Server, and Amazon own service, Amazon Aurora. Yeah, so Aurora is kind of the newest and the most advanced database service, which is MySQL and Postgres compatible relational database. Yeah, that is very fast and reliable, but also it's simple and cost effective to run. And it can scale up to 128 terabytes of storage, which is quite big. And so probably, yeah, I'm not sure who's running this big database in real world. Yeah, and also with Aurora serverless, you can use on-demand scaling. So basically, even when you have no users, it can scale down and shut down your database. And when your user starts running your application, it starts up and scales the capacity to match with your application needs. So this is very interesting because in that case, your database completely shuts down where there are no users. For example, if your users only access your application during the day and not during the night, then you will be able to save a lot of money because Aurora serverless will automatically shut down after that time. Yeah, and RDS is the database service. So there are a couple of instance classes that you can choose for your database. So the general purpose, which is basically for all database needs, memory optimized for more, for bigger RAM in the instance, and also burstable performance. Yeah, and the very cool feature is that with database, if somebody runs the database, you know that there are a lot of manual tasks that you have to do for database. So for example, creating backups, restoring the backups, and making sure that the backups are consistent, and you are able to restore the backups. But by AWS, it automatically creates snapshots and database backups. So for example, every night it can create a snapshot of your database and store it in S3, and later it can be restored in case something bad happens with your application or database. Some developers might basically destroy the database. It can be restored easily, and it also stores transaction logs, so you can restore the database with up to 5 minutes. So yeah, you will only lose a bit of data.
What's the difference between a backup and a snapshot?
Yeah, so the backup is automatic, basically created by AWS, and the snapshot you manually configured for AWS to create a snapshot, and it will create, it will take the whole data of the database and store it in S3 securely. Yeah, that's pretty much it. And also, there are also transaction logs that can save and be, so if you only, so yeah, AWS, when you restore the database, AWS will automatically know how to restore it. So that's also quite useful. Okay, so now maybe let's try to create some kind of database here as well in the console. Let's see how much time we have. Yeah. Okay, so let's go to the RDS console. Yeah, and here actually AWS very pushes the Aurora database, so they always talk about this, but we can select any database we want here. Yeah, so here you can see all the supported database engines. So MySQL, MariaDB, PostgreSQL, Oracle, or SQL Server. So let's just launch MySQL database here. Yeah, and here there's the templates. So since we are just using for development, let's create dev test that will launch only one instance. Let's create a database name, DB. Okay, let's create a password. Yeah, and you can also specify the instance type you want to use. So here is the cheapest and available in free tier is the T3 micro instance, which provides 2 virtual CPUs and 1 GB of RAM. And here I can also specify how much storage I need for my database. So we can see for MySQL, the maximum size is 16 gigabytes, I think. Yeah. And there's also storage autoscaling, so database can grow in storage. So when your when AWS sees that you need more storage, it can automatically provision more storage for your database. And there's also different approaches. So for example, it can create the standby instance that can be used for failover. So for example, when your instance, one database instance might not be available, it will automatically configure the traffic to go to a different instance. But for our case, it doesn't need to do that. Okay, so let's create a new security group. RDS SG. And here I can specify the availability zone, or it will launch it into random availability zone. But since I know that my instance is in EU North 1A, so I will create the same availability zone. And here even AWS estimate the monthly cost for this instance, but if you're using free tier, it will be for free for a month, for the month. Okay, so let's see what happens when I create the database. Yeah, so the database is creating, but since I created my security group, I also need to modify that security group as well. Because probably now it doesn't allow any traffic to enter the instance. It actually does, but I'm not sure what kind of IP address is this. So let's go and see what are our IP addresses of our instances as well. So I can use this private IP address. Let's find out what it is. So yeah, I can see the private IP address of these two instances, and I can add this IP address, or even I can add the security group of my instances. So for example, I can select copy this security group name ID. Okay, and let's go to the database security group, and I will allow web security group. So I will set allow So by doing this, we can make sure that only our web servers can access this database and no one else can access this database unless they launch with the same security group. So yeah, this is the most secure way to do that. So you can make sure that only your application can access, but not other components inside your account. So even if I launch new instances, if it doesn't contain this web security group, it won't be able to connect to the database. Yeah, and I think since database is provisioning, so let's go back to the slides to learn more about.
We go on to the slide. I actually have a couple of questions from people here. First of all, are all databases are in S3, or is it just the backup instance? I'm guessing that the question was about the backup instance. So is the whole RDS in S3? Like, what is the relationship between database and S3?
So so all the databases, they only use S3 for storing the backups of the database, but actually the backups are stored also in the background. So generally, let's go back to the console to show how it looks like. So here's the snapshots, but now I don't have any snapshot unfortunately, but when I create a snapshot of the database, I will be able to find it here. But in the background, it's stored in Amazon S3. And there's probably some kind of action that I can export it to a specific S3 bucket. But in general, when you create a snapshot, you don't see the S3 bucket, you can see the snapshot here and use that snapshot to restore the database. Yeah, however, I know the Amazon Aurora, it uses S3 for storage in behind the scenes as well. But yeah, it's just how AWS implemented, and there are not, I think, a lot of public information how exactly it works, but yeah, probably it uses S3 for storing of your database data as well. But in general, when I simply launch RDS, MySQL or Postgres or any other than that, it stores the data in the instance itself. So here in the B instance, I can find my instance. Yeah, and it will store on this T3 micro instance data.
Then a follow-up question from that is, can we move databases in S3?
Not exactly. Yeah, I didn't exactly understand this question, what it means.
Yeah, I would guess, from what I'm guessing, because we don't necessarily have a database in S3. I'm guessing that it's they're talking about the snapshot. If we have like a snapshot in S3, can we move the database? Can we move the snapshot?
Yeah, so yeah, we can see it later because I think now it's creating a snapshot already. So after the snapshot is ready, you can basically, yeah, restore the snapshot or copy the snapshot or share with other AWS accounts or even export it to Amazon S3 or delete it. So yeah, it's up to you how you want to deal with this. And you can also configure permissions to allow, yeah, other people to read the snapshot or restore it in their own AWS accounts. So it's pretty flexible to what you can do with the snapshot, but since it uses MySQL, so you cannot simply change the database engine. If you want to migrate from one database engine to another, you need to use either to launch and migrate data yourself or use Amazon Database Migration Service.
And can you add a new domain from the security group that includes the database?
Yeah, I also didn't really understand the question.
I'm not sure if Simeon could elaborate on the question because I'm just quoting the question here. So yeah, you can probably continue, and Simeon, if you could clarify your question a bit, and then we'll come back to you on that one.
Yeah, maybe just to give more detail about security groups. So yeah, you can assign security group to one or more AWS resources. So here we can see, yeah, we created 3 security groups right now. So yeah, this is one for load balancer, this one for instance, and this one for RDS database engine. But if you want, you can create more security groups or less security groups. You can even use default security group for everything. But yeah, this is the least secure, and you don't want to do that ever. So probably the best way is to create, try to logically group your resources and then create the security group for these resources. So you list load balancer, your instances, and then your database layer. Or for example, if you need some rules that are applied for all of these, like you need some, for example, you need to be able to access database, load balancer, and RDS from your own PC. So we can create security group and apply the same security group for all three resources. So we can apply the same security group to, because yeah, all of every resources can have one or more security groups, so you can assign more security groups to the same resource if you want to. That makes sense. Right, so let's move on to autoscaling again. Yes, so as you saw right now, so we had our application, load balancer, and then a couple of EC2 instances running in the background. But what happens, for example, if our website, our ice cream shop becomes popular and many users want to access it, then it might be that our instances become overwhelmed with users, or maybe during the night there are not many users. So why do we need 2 instances? Maybe one is enough. So you can So not currently, yeah, how can we optimize performance? We can actually manually create one or more multiple VMs or EC2 instances in the region, or we can use EC2 autoscaling. When launching our EC2 instances, that will scale up or down based on some metrics. Yeah, so autoscaling helps to optimize performance by automatically scaling our instances up or down based on some metrics. Yeah, so if we implement autoscaling, when users enter our web page, they will go to the Elastic Load Balancer, and the Elastic Load Balancer will talk to autoscaling group, and it can make sure that, yeah, if more users are coming, it will launch a new instance. If some instance is unhealthy, it will automatically replace if it will automatically basically kill one instance and replace it with the new instance that is running. Or if during the night there are not many customers, it will scale down and keep only one instance running. Yeah, so the benefit of autoscaling is that it automatically scales in and out by adding or removing keys to instances. It ensures that we have minimum or maximum number of instances running. So you can specify, for example, if you don't want to pay for more instance, you can specify that you want not more than 10 instances. And even if a lot of customers come to your website, it won't scale up. So you won't get a surprise bill. And also minimum instances as well. You can specify that you need at least 2 instances, and it will never terminate less than 2 instances remaining. An advantage is that autoscaling automatically register new EC2 instance with load balancer, so everything is automated. So if you have load balancer, autoscaling, and load balancer, autoscaling or EMI image, you can be sure that basically your infrastructure is kind of automated. So even with something bad happens to your application, it can recover from that, and it can handle the traffic increase, it can handle the instance failure and some stuff like that. Yes, this is just another diagram. What happens? So the minimum size is how much you need minimum instance. So usually it's either 1 or 2 instance if you want to be more secure. Desired capacity is how much instance do you want now to be run, and maximum capacity is what's the total allowed size for your autoscaling group to increase in size. Yeah, so as mentioned previously, autoscaling reacts to instance failure encountered during health checks. So as we saw previously, without autoscaling, when our instance was not operational, it simply stopped sending traffic to that instance. But with autoscaling, it would terminate the instance and launch the new instance with the same properties. So yeah, that will help us. So because when we simply use Elastic Load Balancer without autoscaling, if some instance stop responding, it simply stops sending traffic, and that may cause other instances to be overwhelmed with too much traffic. Yeah, and you can also schedule your scaling. So if you know that the big chunk of customers, if it's, for example, Black Friday tomorrow, you can simply set times for your autoscaling to launch new instances and later scale down after your customers leave your website. And Amazon has a cool feature which can predict the scaling. So it analyzes your web traffic, and it can scale up or scale down based on existing data that you have. Yeah, and benefits is that autoscaling is free of charge. So AWS, you only need to pay the instance that are provisioned, but not for the autoscaling service itself. You don't need to calculate or guess the capacity needs. It also allows us to manage change and automation. So for example, when you create a new AMI image, you can register that AMI image with autoscaling group. And by doing that, you can roll out the new release of your application basically by simply using autoscaling and terminating the old instances and launching a new service. And also allows you to adopt consumption model, so you only pay for what you use and not for the idle resources. So I guess Not sure if we have time to implement autoscaling, but we can probably try.
Yeah, I feel like we can do a very quick attempt.
Yeah, let's see how it will work. Because we already have the AMI image, so that wouldn't be that hard. So let's go to.
But just to clarify, autoscaling, can you use that with other services besides EC2?
So with EC2, yeah, so there are different services. So this is EC2 autoscaling, which is here. And there's also AWS autoscaling, which is some kind of different service, which is, which is different service that can be used with other resources, but EC2 autoscaling is only used with EC2 instances. So let's go to autoscaling groups and create autoscaling group. Yeah, but first I need to, so yeah, the ECG for autoscaling group. And I also need to create a launch template. So let's do that. So launch template simply specify what kind of instance I want to launch. That. Okay, so now I create an EMI image. So let's try to find our EMI image that we created by searching web. Yeah, it's here. Okay, so here I can select the instance type that I want. So let's select 3.3 micro. Yeah, key pair with that we already have this web key pair. And here I also specify where I want to launch my instance. So it's VPC. And let's select the security group that we created as well. Everything else looks good. So let's add some environment variables as well. So environment def and let's also create a name for our instances. Name def. Yeah, so I think it should work like default, and we can create autoscaling group as well. Here. Yeah, so I can update, and our launch template is here. Let's click next. And it's important to select all the available subnets, so it will launch the instance only in the subnets that you select. So since we want our application to be available, let's select all 3 availability zones. So Nord 1, A, 1B, and 1C. And let's click next to see what's here. And we can also attach to existing load balancer. And we can select web target group as well. And let's leave everything else by default. And let's select what's our desired minimum and maximum capacity. So let's make it a 2, not 1. And we can also create a target scaling policy. So for example, I can set that on average CPU utilization. When it reaches above like 50%, I want to launch 1 more instance. But if your traffic is consistent, you can simply use autoscaling with no autoscaling policies. So in that case, it will just keep your desired capacity, but still useful, because in that case, for example, if our instance, one of our instances is not healthy, then it will launch a replacement instance and it will terminate the previous instance. Okay, so let's keep everything else as default and create autoscaling group. Yeah, and it starts to work, and you can see with monitoring what happens right now. And yeah, let's check activity to see what it's doing. Yeah, so nothing happens here, but it will launch 2 instances right now. Yeah, and I can see that it already starts to launch some instances and registering them to the load balancer. But you can also see that yeah, our previous instances are still there that we created manually. So probably in the future you want to terminate these instances and only use the instances that are creating and maintained by autoscaling group. Yeah, and later, for example, in that case, if you want to okay, autoscaling groups. If you want to update the image, so you can update the launch template to change the AMI with your new image, and then it will update the instances with this new image.
In autoscaling, could you show where you can schedule the scaling? I'm guessing that's what's being asked by Simeon here.
Okay, let's see. So let's go to autoscaling group. Yeah, here I can create a schedule action. So if I go to autoscaling, select autoscaling group and click create a schedule action. Yeah, I need to create a name. So let's see, like stop at night. And like I can set desired capacity 0, min capacity 0, and 0. And I can say like every day to do that. Let's make it today. Okay. So for example, if I don't need my application running at night at all, so I can simply do that. But of course, I need to remember to create another action to start during the day. So if you have like development environment and your developers only work from 8 to 5 p.m., you can also do that. So you can automatically stop your development environment and then start it in the morning when we start working again. And let's see if our actual autoscaling group is already running or not. Yeah, it looks our instances are launched, but are they registered to the load balancer? Let's go to the load balancer in the left. Yeah, and here, yeah, I can see 4 targets already. So there are the instances that I added manually, probably these 2, and also instances, and also instances that are created by autoscaling group. Okay, so maybe let's try to see quickly what happens if I stop the instances, what would autoscaling group will do. So I would stop 3 of the instances. And also you can see that autoscaling group creates some tags, so you can be sure that it's, yeah, since it's managed by autoscaling group, so it can create some tags with what autoscaling group it belongs to and the template version and launch template ID as well. So if I go to autoscaling group again, let's see what it shows like. Okay, so it sees that the instance is unhealthy because I stopped it, and it immediately launched the replacement instance to replace that instance. So that's what happened here. And later it will register this new instance with the load balancer, and it can be used to handle the incoming traffic. And if I go to my load balancer URL, you can see that everything is still operating and running correctly. Okay, yeah, I think that's it for me.
Okay, amazing. Thank you. I will share my screen really quick. So for those who have any questions, you can feel free to quickly pop them in the chat. I have a few just like follow-up questions. First of all, going back all the way to EC2, because we started from like one instance, right? And then we launched the second one for fun. But how does one know how many instances to actually launch? Like, what is a good number to start with to make the architecture still resilient?
Yeah, so definitely, yeah, one instance, it's only the starting point, but you probably don't want to use it for any production use case because there might be some disturbances and one instance might fail. So probably just using autoscaling groups. Yeah, the architecture that we created in the end with autoscaling group with 2 instances and T3 micro instances should probably good enough to handle medium workloads. And if you need something, if you need, yeah, you can simply AWS encourage to experiment and find and check what exactly you need. So basically, you can create autoscaling group based on your instance utilization. Yeah, and scale up or scale down as needed.
And another thing, this is something that I was trying to open before, but we got one question from a person who doesn't know if this is relevant to everyone or only to their organization. But they mentioned these kind of subscription levels, and it's kind of like, it sounds to me like IAM access roles, but maybe you can clarify. I don't know if this is in your kind of field, but they have the full list of administrator, API user, billing, power user, security auditor, support user. Do you know if these are IAM access roles or something similar? And how do they differ?
Yeah, so these are probably IAM roles, and yeah, so I think, yeah, IAM management is a different perspective, but probably yeah, what AWS recommends definitely create some different policies for your different accounts, and these should be based on your organization. So for example, if developers only need to access certain services, you can create policy that limits them to certain tasks. So for example, you can limit them for terminating the instances or limit them from launching very expensive instances. Yeah, so it's up to you to define the IAM policies, but AWS provides the best practices, and the best practice is actually to have like the least amount of privilege that you need to do your job. But yeah, you probably shouldn't be too restrictive as well, because then it will impact your job. Because like, yeah, if someone is working and they don't have access to do something, they might be a bit frustrated with that.
Yeah, and if I remember correctly, one of the main like best practices from AWS is never to use the root user for, well, anything, right?
Yeah, correct. So yeah, so you could, when first you create account, you get a root account user and password. Yeah, but you should probably just save it to some password manager and then create additional IAM users that can be used, because with root user, yeah, it has like a lot of power, but also a lot of bad things can happen. And also if the credentials are lost, your whole account will be compromised.
To answer Mendoga's, yes, the training is recorded and you are supposed to receive it tomorrow, the recording, I mean. So if there are no other questions, just wanted to thank Laurynas again. We do have some time to answer any more questions if any ones pop up, but otherwise, if you found this interesting and you would like to learn more, especially from the ground up, maybe even get AWS certified. I just wanted to remind you that we are offering 35% discounts on the most up-to-date and comprehensive certified cloud practitioner course that is currently on the market. It is really, really a bargain. So snatch those deals while you can. You can even book private mentorship sessions with Laurynas here. And yeah, if you have any more questions, obviously contact us at academy@bitdegree.org. We can connect you to Laurynas. You can ask more about the course. If you're interested about other events that CloudVisor offers, because these workshops keep happening on and on. So email events@cloudadvisor.eu. And I would just once again like to thank Laurynas for taking the time out of his busy day to share his expertise with us. And thank you to both CloudVisor and BitDegree to getting us all together for this workshop. If you have those questions, contact us, reach us at academy@bitdegree. Otherwise, thank you everyone for joining us. And we definitely look forward to seeing you in a future workshop or maybe at our BitDegree Academy Cloud Practitioner course. So yeah, that is all. Until next time.